All right, everybody, thanks for joining us today. I'm Sean Spediacci, a senior product marketer here at Fivetran. And we're going to be talking about ETL versus ELT and why the TA shifted. ETL, as many of you know, stands for extract, transform, and load. And what we're going at is that ETL is a traditional method of dealing with moving data from source systems to a destination, and ELT is a very new way of managing all of this. But let's get into the beginnings of ETL. Now, the problem that we've all been trying to solve for is centralizing data. We're moving these operational systems, the Stripes with all of our payment data, GitHub for internal operations, Oracle for all the different applications that we're running, Salesforce for CRM, you get the idea. And all of this generally, we want to move into some kind of modern data warehouse. This is the goal that we're all striving for because we want to do internal analytics, data sharing and building data products and build operational dashboards that we could all rely on to make decisions each and every day as we run our respective departments and businesses. But there's a problem, and it's a really hard problem to solve for when you're talking about each one of these steps of extract, transform, and load. The traditional underpinnings say that we need to generally build some kind of customized script for that extract because each data source is unique and it's unique to us as an organization. And so we need to, every time that data source changes, we need to update our scripts and we need to update our ETL pipeline. And then we need to do the transformation because the data doesn't come pre-prepped in a way that's ready to use as soon as we bring it into a centralized location. We need to accommodate for the amount of storage we have in terms of those constraints before we had separation of storage compute. And then we needed to avoid using overutilizing the compute of the underlying destination and do the transformations of this data to prep the data outside of the data warehouse. And then we need to figure out how to load it and load it efficiently without overloading the system and what is an effect of redlining the system, especially if you have a lot of concurrent jobs and people accessing that system at the same time. That's the general reason why we went to this ETL method. And in order to get the data out, it looked like this. I need to understand more often than not an API call or several API calls. And then I need to design that schema. And when I'm designing that schema, what I'm actually doing is getting requirements from the line of business. So if this is marketing, if this is finance, if this is your support team, all of this is dependent on what is the end report going to look like. I need to know what the data is going to look like when I put it into that end system. And then I'm going to write that CSV, prepare the destination by writing the schema, and then loading the data. And then I'm going to merge that data together to get a table that I could actually use for a report and then build my BI reporting on top of that, which is an additional step that isn't outlined here. Now, what does that look like from an actual pure operational standpoint? A user will ask the analyst that they needed a report, but the analyst doesn't have access to those metrics. And then they go to their IT team and say, I need access to this data. How do I get access to it? Do you have a way to pull this? They will generally work with a data engineer of some kind who then has to go and figure all of this out. And then they need to go back and return and verify that data every step of the way based off these requirements, making a huge chain of problems before it gets back to that analyst who then says, this isn't exactly the data I needed, or I need different data, or maybe that report breaks because the underlying data source has changed or a schema has changed. All of this creates huge dependencies and huge backlogs internally, and that's because we've relied on this ETL system, this ETL approach where I have to extract the data, transform before loading it in, and then load in that data and then hope it's the right answer. So what we're not accounting for are things like API changes. What happens if the underlying API changes? Then the report can either break or it doesn't have, the analyst doesn't have access to the data that they were expecting or expect to be there in the first place. So then you have to create that whole system of tickets again just to get there. If your database source schema changes, you might have, yet again, a breaking of your entire pipeline or the report itself, and you need to go back and fix that, and you'll have delays in your reporting internally. And if you have an immature pipeline and you're doing these through full table extracts, it could be really resource intensive on the source side, meaning you're calling the API multiple times, and maybe you're stressing out the number of APIs you actually have available to call each month. And then what if you need to refresh that transform data? If that data that you've already pre-transformed you need to ask a different question of it, you then need to go back to the source system, pull it, and then redo that transformation. And that's when you've really gone beyond the scope of the original question that you've asked. All of this, as you've heard, it's slow to set up when you're building these pipelines. It's slow to pull data, and it strains not only the system itself of the technical bits, of pulling from the source system, building the pipeline, and then all the way to loading into the data warehouse. But it's actually cumbersome and strain on your internal operational systems, because people are constantly waiting for data that they don't have access to, or they just go about doing it another way by pulling it directly from that source system, and maybe doing it in an Excel spreadsheet or Power BI, just anything they can do just to get their job done, when it can be done much more efficiently and at scale with a much better system, a set of systems. And then overall, these are very cumbersome to modify. How do you actually modify each one of these when you have your requirements change? And you need to account for that each step of the way, but it's hard when you have limited resources, and especially when you're doing this in an ETL format. Now, this is where ELT comes in, and really ELT has come in this modern approach because cloud data warehouses are fast. They're fast because we've separated storage compute, and we're no longer tied to this physical limitation of I can't store all my data because I have such a limited amount of storage and also a limited amount of compute. You can scale those up independently. And so ELT is now the preferred method because we get access to all the data as well as access to all the compute that we need. And so we have a simple modern data stack here where we're pulling from different data sources, just as we were before, your applications, your databases, maybe your event connectors, as well as different files, and you're pulling that all into the data warehouse so that way you could run the business intelligence. But what you're really doing is replicating data, replicating from one to the other and moving it into normalized schemas. At least that's what we're doing here at Fivetran, is we've actually pre-done all of the schemas for our applications, and you could look at our documentation and find entity relationship diagrams, ERDs, designed for each one of our applications, like NetSuite, like Salesforce, like Zendesk, everything that your business relies on. You'll find those normalized schemas where your data is already pre-transformed and loaded into your destination, ready to be analyzed. Now, what's happening here is that we've actually moved the loading of the data directly into the destination, and we're no longer transforming outside of the destination. We're now relying on the data warehouse's very powerful, fast compute to do that transformation for us. So when we pull the data from these different disparate source systems, we're pulling it into the data warehouse now, and we're running those SQL transforms inside of a Snowflake, a BigQuery, a Delta Lake, a Redshift. All of these systems are powerful systems designed to do fast, powerful compute, and we don't have to worry about concurrent workloads. And then we move all of this data, as I mentioned before, loading it into these normalized schemas ready to be analyzed. And then if we want to do additional transformations, we can, but this is all powered by incremental updates. If we need to move data from one source system into the destination, we're now able to do this not as full table refreshes, but as incremental micro batch updates, moving, if only the data is changed in the source, we will make and append a change to the destination and to that specific table. And if we're trying to do transformations, if we would like to do additional compute inside of the warehouse based off of whatever tables we're landing in, we can, because we're actually able to take advantage of these powerful data warehouses. And that allows for flexibility, because when we're doing post-load transformations, what we're saying is we're loading the raw data in its fullest fidelity into the destination, and then having a secondary set of tables that are actually our gold standard schemas, and our schemas that have all the transformations and the modeling done for us. So all of this is done inside of the data warehouse, not outside of the data warehouse, which enables that flexibility. And ultimately, because we are moving this data into the data warehouse, into normalized schemas, we're no longer worried, is that data ready to use? As a data analyst, I am actually able to look at these pre-done ERDs, entity relationship diagrams, and I'm able to see that we're extracting, loading, and I can now analyze that data right away, because I can see the relationships between the data and build the reports that I need. And then all of this is using the ELT methodology. Now, when we talk about this, when we're talking about ELT, the reason why we did ETL before is because we did certain transformations before we hit the destination, before we loaded into our warehouse. The common use cases here are those where you need to standardize field names and create reporting tables. All of this data type transformation mapping from source to destination, which can be automatically done with Fivetran. Deduplication of data, making sure we're not moving the same row over twice or 3 times over, and tracking changes between history and the destination, and doing that micro batch architecture of only incrementally updating the table when we need to. Now, all of this is done either automatically by Fivetran, because we're taking advantage of it, and we've actually pre-programmed all of our all of our connectors to take advantage of this ELT methodology. But we're saying that transformations of creating the reporting and tables should be done by you, the customer, inside of that data warehouse. Let Fivetran move that data into the destination for you with our defined ERDs and already pre-built connectors. And then you can take advantage from there of doing the transformations inside of a Snowflake BigQuery or a Delta Lake. The solution ultimately for us is an automated, resilient, and deployed in the cloud data pipeline, where Fivetran creates and maintains that perfect replica of your data with minimal user intervention. We're not asking you to code these pipelines. They're pre-built, ready to go for you. And it's resilient. We have an idempotent core architecture, which means that we're resilient for us to write high quality connectors internally here at Fivetran, but it's also, if we were to run into any kind of issue with a source system or a destination, we can then retry and recover from failure quicker and without error and without moving duplicate data over into the destination. And it's all deployed in the cloud, so our engineers can constantly monitor and fix the source changes. One of the things you will constantly need to do if you do manage your own pipeline is stay on top of it and be on pager duty in case that thing does break. But with Fivetran, we're on the job and we're going to take care of that for you. And here we'll take questions.